Okay, sweet. Well, since you're the only one here,
Howdy.
also, my name's Kenna, by the way.
Carly.
Yeah, I'm assuming you already know Carly.
Well, we just met an hour ago.
Oh, okay, well, so impressive. Well, we'll just go through this, kind of just goes over each of the problems on the CBE. So we can run through them, we'll like explain the concepts behind them and then run through example problems. And then, since you're the only one here, stop us if you have questions.
Yeah.
We'll like run through anything faster or slower, whatever. So yeah, covering lessons 7 through 13, all of these different topics basically, which is what we're gonna go over step by step in here. So starting with polynomials, just some definitions. You have a polynomial is just a finite, so there's like less than infinity number of terms, where you just have a bunch of constant variables with coefficients and exponents. So the terms are each of the pieces that are added together. So like 4x cubed is a term, 2x squared is a term. And then the coefficients are the numbers in front of the variables. So 4 and 2 and 1 and 1 are all coefficients. And then the degree is the degree of the entire polynomial is just the biggest exponent.
Gotcha.
So this is a third degree polynomial because our biggest exponent is a cube. So yeah, so just when we're going through that, well, that's the terminology we'll be using. So for this guy, we're going to start by just subtracting these two polynomials. So biggest thing on this is remember that when we subtract them, we're subtracting each term on the second polynomial. So how would we go about this? How would you
I
solve this?
distribute them.
Gorgeous. Let me see if this is gonna let me write. Okay, incredible. Now there's just gonna be that because it doesn't tap to give me the eraser, but 4m, and then we'll distribute that negative to each term. So minus 6m cubed plus 4m squared m plus 5. Gorgeous. And then from there, what would we do?
I just subtract.
Yeah.
M cubed.
Exactly.
7 squared.
Just like the combining like terms.
Yeah.
Yeah, gorgeous. So we'll have negative m cubed plus 7m squared plus 3m plus 5. And allegedly that's correct. Gorgeous. Okay, sweet. So yeah, you already wrote that. So sweet. And then for this one, determine the value of the polynomial 2x squared plus 3x minus 12 when x equals 3. So how do we solve that?
You just plug in the 3 essentially.
Yeah, just anywhere there's an x, we'll put a 3. Yeah. So 2, so we'll put a 3 here. A 3 here. Yeah. Trying to talk and write numbers down at the same time, like my brain.
I do have one small question. I think I know this is right, but
yeah,
we put the exponent in first, correct? So for the 2, 3 squared, it's gonna be 2 times 9.
Exactly.
And then we're gonna get 18.
So
just
yes,
order of operations.
Yeah, order of operations, we'll do this exponent first right here, and it only applies to that 3. It doesn't apply to the 2.
It
Yeah.
only applies to what it's like directly touching.
Yeah.
Like touching it talks about that.
Exactly.
I should know if you did that before or after. Well, I did, but I'm just kind of questioning.
Yeah, no, that's perfect. So yeah, we'll make this 3 times 3, which is 9.
Yeah.
And yeah, so we'll do that first.
Okay.
And then we'll multiply by 2 after. This one is also gonna be 9 and minus 12. So yeah, we'll have that 18 like you said,
Okay.
plus 9 minus 12. Which equals 15. I don't want to try and do that algebra, so I'm just going to trust the quotient, because if I try and do
27 minus 12.
if I try and do that in my head, it'll be really embarrassing because I'll probably get it wrong. Cool. Down to this section. Okay, sweet.
So remember, multiplication is commutative, so you can switch them all around, and it's still going to be the same result. Like in this thing here, 3 times 5 is the same as 5 times 3. And a thing to take note of in the second example, where it's 3x plus 7 multiplied by x minus 1, so they're in parentheses, so it's the quantity. So if we had switched like the x and the 3x, that's not keeping the commutative property, it's the quantity together in the parentheses that we can kind of move around.
Gotcha.
Does that kind of make sense?
Kind of. So we can. What do you mean by that? So we can swap around the x values?
Yeah. So we can swap around like this quantity, like, so you see how from here,
Yeah,
they have moved around to, on the other side of the equality.
yeah,
So we couldn't necessarily move, like, switch the places of the 3x and the x, that would change the value of it.
right.
But the quantities that are multiplying the factors,
gotcha,
we can
okay.
change the location of the factors,
Gotcha.
as long as everything's multiplying, everything is a factor, we can change it. So this whole thing is
So
a
you can't move
factor,
the x's, you can move the,
right? So you can only move the whole factor, the whole thing that's multiplying,
gotcha.
so. Hi, Heidi.
Come on.
Damn, I'm always seeing people's names, but Heidi doesn't care. And then also when multiplying polynomials, we use the distributive property.
Right.
So remember, when something's multiplying by something that's adding, it goes like that, and that gives you that, right?
Yeah.
So, but if we had like A and B like that, if they were multiplying in there, remember, those are all factors, right? So
Yeah.
it's not going to distribute, it's just going to be A times B times C.
Okay.
So
Gotcha.
just something important to keep in mind. That will really help you on the CBE. Remember that. Okay. Okay. First problem. Okay. So we're going to multiply and simplify this expression. How would you start?
Well, you just distribute the 4 to the 3 and then the 3y squared and then the negative 3y, 4, and then you just do the same thing with 5. And then you're gonna combine like terms after, whether it's an addition or subtraction.
Beautiful process. Yeah, you got it.
You should see me try to do math.
I
She's
mean,
why
I'm
we
literally
watch-
seeing you
watch
try to
this
do
show.
that right now, it's great.
Appreciate it.
Oh, crud. Okay. Don't look at that. Okay. So 4y times 3y squared would give us 12y cubed. And then minus 12y squared. And minus 16y. All right. So then 5 times 3y squared equals 15y squared. Then minus 15y minus 20. Does that kind of make sense how that multiplying went?
Yeah. You have
Okay.
a positive 3y.
Mhm.
And then.
I'm gonna
negative-
sort my terms,
Okay,
okay?
sweet.
That's gonna help me be accurate.
I usually just like cross them out. I had a math teacher that like, she had us use like a table, I can't even remember how we had to do that. It was weird.
Everybody's got their preference, I suppose. Okay, so from there,
Yeah.
Fair enough.
so that's 3y squared, right? And then negative 16y minus 15y is negative 31y. And then minus 20. Does that kind of make sense how we got there?
Yeah.
Don't even worry, I've already checked the solutions.
I know, that's what I did like in the last 30 minutes, so.
And then we'll do this problem. Okay. All right, so this is more of like a word problem.
Yeah.
Are you familiar with that terminology? Like of
Yeah.
like an application-based thing. So we're solving for the area of a rectangle, and the area is equal to width times length. So they give us what the width equals, and they give us what the length equals. So our area is going to equal
Okay.
3x minus 8, right?
Yeah.
And then times the whole quantity of 2x plus 7.
Then we're just
That
gonna
makes
FOIL
sense.
that, right?
Yes, yes. Okay. Mhm. So a FOIL. Love me a good acronym.
PEMDAS, we learned one for PEMDAS where it's like,
Please
please excuse my dear Aunt Sally.
And you know how Janet says it, she's, please excuse my dear
Many
Aunt Sally. Because it's like multiplication, division are like she says, like they're like siblings. So they happen at the same time. So they're not necessarily like, you don't have to do multiplication first and then division.
Right.
So
Either one.
yeah, if that makes sense.
Mhm.
Okay, so 3x times 2x will give us 6x squared minus 16x plus 21x minus 56. Times tables coming in handy. Okay, and then are we done?
No, you combine like terms right there. Then we have 5x.
Awesome. All right. What?
I said gorgeous.
Oh. Slay. Okay. All right.
This is the weak point that it has.
No, you got this.
Yeah, you do got this.
Okay,
Walk through it.
so when we're dividing by polynomials, so I guess first we're checking if it's a monomial on the bottom, which just means there's only one term.
Right.
So like if we have 5x squared plus 3x minus 1, and then on the bottom, you just have 2x or something like that. You just divide each term individually.
Gotcha.
We'll have an example of that on the next one. So you can just simplify one term at a time.
Okay.
You don't have to do long division, but if you're dividing a polynomial by another polynomial, so there's multiple terms on the top and multiple terms on the bottom, then we can't divide individual terms because you can't separate things that are added
Right.
before you divide, things like that.
So,
yeah.
sorry, just, this might be a stupid question, but say we had 5x squared minus, well, that wouldn't apply there. Let's say like we had 3x squared on the bottom and then
Mhm.
2.
So like
Obviously
This
that
was a 3x
3x would
squared.
go with that,
plus
Right.
2 or
We
minus
just-
2 or something.
yeah, if
Okay.
we had that 3x, I'd go with the 3x. But can we not divide that because it's not like term?
Since since you have addition on the bottom
Yeah.
and on the top, you have to, so this kind of goes back to just your fraction rules.
Yeah.
Like you can separate denominators. Let me find the eraser right here. So if we had, using our fraction rules, this is equal to just adding fractions. You have 5x over x plus 3x or 3 over x,
Right.
because that's by definition of just adding fractions. But that means we have to have the same denominator. So if we had something else, if there was a plus 3 right here,
Mhm.
you have to keep the denominator the same on all of them.
Gotcha.
So when you're separating them, you can't separate the denominator.
Okay.
So you can separate the numerator as long as you keep the denominator the same.
Okay.
You can't do it the other way around.
Okay.
Going back to our fraction rules.
That makes sense.
So that's why you can't separate, like if you have a common term in the top and bottom, if there's addition in the bottom, you can't separate it.
That makes it not a factor, like how
Yeah.
talks about in class, so if it's like adding, it's not a factor anymore, so you can't like cancel or divide it out.
Okay, gotcha.
We'll just, and then, yeah, so when you're dividing a polynomial by a polynomial, you can't just do one term like we were just talking about. So instead, we're gonna use long division, which is pretty similar to long division with just regular numbers. But we'll go through that in a couple of examples. Cool, okay. So this one is one of ours where we're dividing by a monomial.
Mhm.
So how can we start this problem?
We don't want to do long division on this one, correct?
Yeah, so we don't have to do long division. We could and it would work, but
Okay.
we don't have to. So
Okay,
since it's a
um,
monomial, what could we do instead?
Couldn't you just, then 9x and 4 and then negative 9x and 4, those cancel out? Really?
Yeah, so these ones cancel out. So what we're gonna wanna do is separate it into multiple fractions
Oh, okay, I
first.
get you.
And so this is like going back to what we did
Right there.
right here.
Okay.
So using the properties of
We want-
adding in fractions, yeah, go
Yeah,
ahead.
we want 3 fractions?
Yes,
9x
mhm.
plus, okay.
Yeah, so every term on the top, we're gonna turn into its own fraction. So this is gonna be equal to 9x to the 4th over negative 9x to the
Okay.
4th plus negative 6x cubed. over negative. Yeah, so we'll go and split it into however many terms are on the top, you'll split it into that many fractions.
Then we don't need, do we need like terms in order to, that's a
And-
stupid question, but
You're good.
we don't need like terms to add all that together, do we?
So now, since they're just one term at a time.
Yeah.
We can go through and just simplify each of the individual fractions.
Okay.
And so with, with that, it's gonna be like division term by term.
Okay,
Because, so now there's not any addition or subtraction left in like this first term
Okay.
or the second term or this third term.
Mhm.
So now we can just focus on like dividing by
Okay.
term. So you can just cancel out similar terms
Okay.
and stuff like that. So like for this first one, that whole thing is basically gonna cancel out except for the
Okay.
negative one, right?
gotcha.
So this is gonna just give us -1 for that term.
Okay.
And then how can this next term simplify?
3,
So each of these can be divided by 3, right? So if you divide 6 by 3,
you get 2.
you get 2. So we'll have a 2 right here. And then on the bottom, if we divide 9 by 3,
We get
we
3.
get 3. Awesome.
Then do those stay negative or no?
And then
You
these
divide it
negatives will
negative.
cancel out.
Yeah,
So a negative divided by a negative is positive.
and then they do they keep the terms? Would it be X, just X on the bottom?
Just X on the bottom, yeah, because 3 of the X's will cancel out, but then the 4th one on the bottom will stay
Okay.
there. Cool.
Makes a lot more sense.
And then this last one, what can simplify?
Not really anything, will they just be -4x to the 4th? Because there's no power or?
Yeah, so since nothing really simplifies, 5 and 9 don't have any common
Okay,
factors
so
to simplify, we'll just have to pretty much keep it the same.
this isn't my strong suit, so
That's okay.
sorry, but.
No, that's okay.
So it just stays 5 over -9x.
Mhm.
Okay.
Yeah, if you can't find any common factors, it's totally fine, just leave it the same.
Okay, sweet.
Yeah, so in this one, I'll just pull that negative out to the front because we only had one and just call it a -5 over 9x to the 4th. Does that make sense? Do you have any
Yeah.
questions there?
No,
Okay.
that makes sense to me now.
Cool. Sweet. Okay, so, and now we have one where we don't have a monomial on the bottom anymore.
Mhm.
We have polynomial. So what does that mean we need to do on this one?
Long division.
Gorgeous. So how do we set that up?
It's gonna just be x - 4 and then the long division sign,
Mm-hmm.
3x cubed minus 7x squared plus 5.
Gorgeous. Okay, and then what's our first step? Like when we're going through long division, what are we gonna do?
Well, we need to get essentially as close as we can to the thing,
Mhm.
to what is being represented there. So it's gonna be 3x squared.
Gorgeous. Yeah, so we're just gonna say, okay, what can we multiply this first term by that's gonna get us to this term? Which is 3x squared.
Yeah.
Gorgeous. So then what do we do with this 3x squared? What do we put down here below?
Yeah, you're gonna get 3x squared minus 12x squared. No, 3x cubed minus 12x squared.
Gorgeous. Yeah, so we're just gonna multiply that term by whatever we put on the top. And then subtract this whole thing. Those will cancel, you'll get, is that 5?
Yeah.
X squared. And then 5 minus 0 is just 5.
Yeah.
Okay, and then what are we gonna do
Um,
for this one?
5x times 1 plus 5.
Mhm. 5x squared, and then this is gonna be a -20x.
You're also welcome to use like a placeholder. Remember how we talked about
Yeah.
that in class? It's like plus 0x, and then you
Yeah.
can bring down the 0x. So you're not like adding terms that aren't like.
So if I didn't use a placeholder and we got there like that, would I just get, what would I get left over? Because you can't, because you're just left with 5x minus 20, because they're not like terms.
So yeah, so since they're not like terms, you can just pull each of them down pretty much. So this is +5 plus 20x.
Okay.
And you can't combine those, so you're just gonna have that 20x plus 5.
Okay.
So
Gotcha.
the placeholder does make it a lot easier to read. I didn't think about doing that,
Okay,
but
so we won't have a remainder on this one, so it's just gonna be, well, we are gonna have a remainder.
yeah, because we have one more step on this one.
Yeah, just gonna 20.
Yeah, just plus 20, so we'll have 20x minus 80.
Yeah.
Cool. And if we subtract that, those will cancel out, and then we'll get 85. Okay, so how do we write our final answer then?
So it's gonna be 3x squared plus 5x plus 20, and then we're gonna have 85 over x minus 4.
You're saying that this is not your strong suit, but like,
Yeah, that was
you
really
really
good.
just like,
There was a
yeah,
lot of time
no,
spent.
you did great. That was awesome. Yeah, there you go,
Sweet.
gorgeous. Cool.
See what other stuff we got.
Yeah, I think this is the last section.
Yeah. Okay, so back to factors.
You have very different concepts.
Yeah, right. Well, that's why the world turns, right?
Yeah.
So, okay, factors are the numbers that multiply together to make a number. So, like we kind of been talking about, we think about undoing multiplication. So we'll look at what we'll divide evenly into our number and then write it as product of those divisors. So we're gonna be looking at our terms and seeing what we can pull out of all the terms.
Right.
And then if we had to multiply that back in, it would give us the same expression we started with.
Yeah.
And then the greatest common factor is the largest factor a group of numbers all have in common. So do you remember doing the greatest common factor stuff a little bit for CBE 1?
Yeah, so it's be like can't remember, but you just get like 5 times 3 times whatever.
Right, yeah, and so if they have common factors, then your greatest common factor is like a little bit, well, the greatest common factor is the greatest number that multiplies into all of them, that they all can be divided evenly by. So it's like
It's
the smaller
20,
number.
10 and 40 have like greatest common factor of like 8. I think.
So it's the opposite. So
Oh, okay.
10,
That's the
40,
least common.
and 20, our greatest common factor in all these would be 10.
Oh, okay, get you. Yeah.
Does that make sense?
Yeah, makes sense.
So the least common multiple
That's where I was.
would be 40 out of all of these.
Yeah.
Does that make sense?
That is one.
So it's a little, it's a little confusing. Yeah, okay, so factoring trinomials when they have 3 terms, that's what trinomials means. Just a fancy way to say that. First write it in descending order and then you'll unfoil it. So when the leading coefficient is 1, you're gonna find the term factors of the last term that add to the middle term. And if the leading coefficient is not 1, you can factor out the coefficient, but if you can't, then you'll have to find factors of the leading coefficient multiplied by the last term and then that add to the middle term.
Okay.
So that'll become more clear when we do the example, but that's probably, in my opinion, the hardest factoring problems is when they have that leading coefficient because it just adds a level of uncertainty.
Yeah.
So
I don't like it.
yeah, you're real for that.
Yeah, I don't like it either, and I've been doing math for I don't even know how many
Yeah.
years, so.
Are you sorry, but are you a junior?
I'm a senior, yeah. I'm 23,
Oh, okay.
I'm so old, you guys, sorry, I'm grandma.
No, that's not. I was like, I just was curious, but, okay. Fully factor this polynomial. Okay, how would we do this? Do we have a leading coefficient?
No,
Okay, so our life is really simple.
it's really nice. right
Yeah.
now. It's just gonna be x minus 2 and, I mean, x plus 2, no, x minus 2. And then x minus 1.
So kind of how did you go about that?
I just, you know.
You developed the math intuition. That's awesome.
I
That's where we're trying to
guess.
get. Yeah.
I just know negative is positive is negative. So-
Right. Uh-huh.
So you just have to get the 2 negatives
Yes.
and then, 2 plus 1 equals 3. So
That's
just
an
try to-
awesome line of thinking. Because if we have a positive sign here,
Mhm.
we know that the only thing that creates a positive when multiplying is 2 positives or 2 negatives.
Right.
But since this is a negative sign, that means that we're gonna have 2 negative numbers.
Yeah.
Does that make sense?
That makes sense.
So that's exactly what you said. So, yeah, you got it. So we know that there's a negative sign here. And since it's just x squared, what would our first term be?
X.
The only thing that can multiply to be x squared is x times x. So, perfect. Okay, and then like you said, this 2 here, the only thing that can multiply to be 2 is 2 and 1.
Yeah.
And since these look identical except for those factors, and we can just plug them in. So, yeah, but perfect way to go about it. You did that really well. So,
All right, now give me the leading coefficient.
all right, it's coming. Don't worry. It's on its way. All right, here it is. You asked
Okay.
for it.
So I actually had quite a bit of frustration when I did this. whole
Okay.
thing. So essentially, the first term and then the
Mhm.
first term, that's gonna make up 8, correct?
What do you mean?
If you multiply.
Oh, the
both
first
together,
term of
that's
our
gonna
2,
make-
yes, yes.
Okay, so it'd be like 4 and 2
Mhm.
or 2. and-
These terms
2
multiplied have to be 8x squared.
And then the last term, the last 2 are gonna make up the 1.
Mm-hmm.
So. Okay, but then.
Yeah,
This is where it
so,
gets difficult.
no, you're very, yeah.
It's
So
like a mental block.
what I would
don't
recommend
understand.
is, this is personally what I do, is I'll write down the factors that multiply to be this first, our leading coefficient.
Mhm.
So we could have 8 and 1 or 4 and 2.
Right.
And so that's all we know, right, from that. But then our last number, this is really nice. Oh, where did you find the eraser? Oh, there it is.
Yeah.
Maybe? Oh, I see.
It's not like most ideal format, but.
I see it. I saw it. Okay.
Yeah.
And the only factors that multiply to be 1 are 1 and 1, right? So that's nice for this problem. We know that our last term in both of these binomials is just gonna be 1.
Okay.
Does that make sense?
Yeah, I'm gonna say it's gonna be 8 plus 1 and then. No.
So let's focus on the signs next,
Okay,
right?
yeah, signs, so it's
So,
gonna be positive.
Yes, so this is positive and this is positive. So the only 2 numbers that add to be positive and multiply to be positive are 2 positive numbers. So we know that this is gonna be positive and this is gonna be positive. And from here, it's just a little bit of a math intuition, trial and error, stuff like that. So we want something that adds to be 6. So which of these factors add to be 6?
4.
Right. So it'd be 4x and 2. So does that make sense? That one was
Yeah.
a little bit cut and dry. Like you said, we kind of walked through it though.
Oh, that's just gonna work?
Yes.
Okay.
That's the
There's no
process.
trial and error
We
on
can-
this one.
We can also break it down to factoring by grouping. I can kind of, if you want to do it that way.
Go for it.
So sometimes I'll think about it, if we take the first term or the first coefficient and the last coefficient and multiply them together. Like in this case, it was really nice because the last coefficient was 1. But if it's something bigger than 1, we'll want to multiply it together.
Right.
And then we'll do that same thing. So what multiplies to 8 times 1? So something times something multiplies to 8 times 1, and also something plus something adds to 6,
Okay.
which is still that 4 and 2, like we figured out, right?
Right.
So it's the same numbers. So that's how you figure out those numbers. But the way that I'll break it down is I'll say, okay, from here, this is 8x squared, and then 6x can be broken up into 4x plus 2x. And then there's that one. And now we can do factoring by grouping, which is what we're gonna go over on like literally the next slide. But,
No, this is great. I am doing this.
and then, so now you can go in and have you talked about factoring by grouping?
Yeah.
Okay.
Yeah.
So I'm
Took me a
gonna,
minute to get there, but I got there.
so now we're gonna say, okay, so what's a like term in this
2.
section?
4 actually. 4x.
4x. I'm just gonna bring this down here. Okay, so we have 4x. We'll factor that out. So you have 2x plus 1. And then do we have any common factors in here?
1.
Yeah, just 1. So I'll just write down a 1 to keep track of that. So you have 2x plus 1.
Oh, wow.
And now we can factor this term out of both of them.
I
You'll
actually
get
quite like that.
2x plus 1.
Yeah, that's beautiful.
That takes
4x
most of
plus
the
1.
guesswork out.
Yeah, this is. I've never like my whole life. You could have saved my whole life if I had known this years prior.
This comes from tutoring that I've had for the last 4 semesters, 5 semesters. But yeah, so I like doing it by factoring by grouping, and it does take a lot of the guesswork out.
Yeah.
But, and then, I mean, we go up for factoring by grouping in the next one, but either way, you'll get to the same answer.
No, it's great, especially like when you're dealing with like 64 and like.
Yeah.
If you,
whatever.
especially if you have a non-1 number on the leading coefficient and the last number, the constant term, it's like, yeah, so this saves my life.
Yeah, that's awesome.
Sweet.
Thank you very much for that.
Oh.
I'm like, I have my little tool pocket. I will be talking about that tomorrow in recitation.
Oh, I'm so glad. Gorgeous.
That's awesome.
Well, now we're all gonna be pros. Okay,
So true.
so factoring by grouping, basically just what we already did. When I was going over the slides, I saw that and I was like, why are we doing factoring by grouping after this? Because I feel like
You could use it.
you need
Yeah.
it for both,
I feel
whatever.
like the strategy that they teach in lecture is kind of like
Is that more
guess
like
and check.
guesswork?
Yeah.
Yeah.
And so, but I definitely I like the way you set it up a
Mhm.
lot.
Cool. Yeah, anyway, so now you have multiple tools.
Just
You can,
always think
you
about
can
it.
attack it in different ways. Okay, so when we are factoring by grouping, it means we have 4 terms. We're gonna put both of them into different sets of parentheses, factor out like terms, and then end up factoring it into 2 terms that are multiplied by each other. Okay, this guy says, factor them into 2 groups. Yeah, and then just factor everything out, basically just like what we just did. So we'll go through that in this guy. So how would you break this up into 2 groups? How are we going together?
Put parentheses around the 5, the 8xy,
Mhm.
and then 56y.
Perfect.
And then just immediately after that, parentheses around the 7, negative 7x and 49.
Okay, so right here, what do we need to remember? So between this, if we write it just immediately there in front of the negative, bless you. If we put it right there, right in front of the parentheses,
Mhm.
it kind of looks like we're multiplying, but we need to remember that we're not multiplying, right? So I'll usually just throw in a plus sign in there, because plus and negative is the same thing as minus. But this negative right here is only connected to the 7, so we don't want to detach them. So if we rewrite that, we have 8xy plus 56y plus our negative 7x minus 49. Cool. And then we can go in and start factoring out any like terms. So in our first one, what do we have?
8
Okay.
and y, 8y.
And y. Cool.
Yeah.
And that's going to leave us with an x plus 7. Okay. And then what like terms do we have in our second one?
7.
7.
Negative 7.
And there's also a negative for this. And if we didn't catch the negative this time, we could pull that out the next time too. Or we could pull it out in the second step. Yes. Gorgeous. And now these two look the same, right? So we can factor that out technically, x plus 7. And what we're left with is that 8y minus 7. Gorgeous.
Sweet.
Nice. We wrote it in a little different order, but that's okay. Awesome. And these are just our special factoring forms. So if you have something that is just a one term squared minus another term squared, that means that you could factor it out exactly like that. The difference of squares is what that guy's called. And then perfect squares are in this form. So you have still that first term squared and then your last term squared. Your last term is positive, which is important to note. And then if you have a minus 2xy, then there's a minus sign on the inside of your squared term. If you have plus 2xy, there's a plus sign on the inside of your squared term. These are nice to remember. You can still get there by factoring by grouping or factoring another way, even if you don't remember them. So they're nice little tricks to know. But if you already know how to factor something, you're going to get to the right answer either way.
Yeah.
So how would you start this problem?
Well, we have 5 in common, 5x cubed, 5x cubed.
5x cubed,
So
great.
you factor that sucker out, and you're left with, was it 16?
Yes, I had to do that with my
Did that
calculator.
earlier, 16x squared, minus 8x. And plus
+1. Cool. So we could go in and do that idea that we did where we multiply the first leading coefficient by the final term and do our factoring by grouping idea. This probably has a special identity as well, because that's what we just went over. Can you see what it is?
Kind of,
Okay, so what are you
that
seeing?
helps.
Yeah.
Well, wouldn't it just be, because we have to get into a square format, so whatever you square has to come out.
Yeah.
So wouldn't it just be 4x? Because 4x squared is 16x, and then 2 squared is 4, so it'd be, that didn't make sense, did it?
That's okay.
2 squared is 4, that.
2
that
squared
makes
is 4,
perfect sense.
yeah.
Well, yeah,
Well, that's
but I'm
right,
trying
yeah.
to get to 8x.
So the 8x, so if we look at, so if we have this x squared minus y squared, right?
Oh,
wait, no, I
okay,
wrote
so it's
that
gonna be 3x, because then you have to subtract that 1. No, don't listen to me. I don't know what I'm talking about.
Okay,
Yeah.
so this is our x minus y. Sorry, I really am trying to write them correctly. Okay, and then minus y squared. Okay, so if we have this identity, then the middle term isn't a squared term. It's your first term minus your last term in here. So what we want to look at is this a squared term and is this a squared term?
Okay.
So like you said, 16x squared is 4x
Right.
squared, that whole term squared. And then can we make 1 a squared term? What squared equals 1?
Would it be negative? No,
I mean, -1 squared does equal 1.
yeah.
Mhm.
It just,
Not a trick question.
That's not a trick
Is it?
question, yeah.
no, isn't it just 1?
1 and
times
-1,
is
yeah,
one.
both of them.
Okay,
Mhm.
I
So,
didn't wanna mess it up. and
no,
look
you're totally good.
bad.
-1 squared is equal to 1 squared,
Gotcha.
which
Okay.
equals 1. So all of those are the same. So you're totally good.
Okay. Gorgeous.
And then we just have to decide, is this gonna be a plus or a minus in the middle?
It's gonna be a minus.
Because like we said in the other one, it has to multiply to a positive
Mhm.
and it has to add to a negative.
Yeah.
So it's gonna be a negative.
So what if they're both negative?
If they were both negative, then it wouldn't be one of our special properties.
Okay.
So
Oh,
If
yeah,
it's-
definitely
yeah.
negative.
if it's one of the perfect squares, like right here, you have a positive on both of them.
Gotcha, okay,
The only time you'll have a negative is right here when you don't have the middle term.
gotcha,
So,
okay.
yeah. And then the reason that this is that like perfect square identity is because 4x plus 1 times 2, or 4x times -1 times 2 is this right here, which is equal to that negative x, negative 8x.
So I only really need to find like the, I guess, unsquared versions of the first term and the last term.
Mhm. And as
and then
long
make
as
sure it's that factor.
that goes to that middle term, yeah. and they will.
Okay,
Cool. And then just make sure we keep that 5x cubed connected there.
sweet.
Cool. I think, yeah, gorgeous. It's a little bit, yeah, I'm gonna be honest, usually I don't keep track of all like the special things. I'll just factor it normally. Sometimes you'll just see it and you're like, oh, those are like, that's definitely a difference of squares, or like a perfect square or something like that. And then it's super nice because then you don't have to do all the factoring. If you don't notice it right off the bat, just factor and you'll get the right answer.
Especially if it's like 49, 14, you
Yeah.
can see that pretty easy.
Exactly. So, yeah. But yeah, I think that is everything that we have on here.